Hi everybody. In this section we're going to learn, or these two sections, we're going to learn how to differentiate log and exponential functions. I've typed up the four formulas we need. The basic ones are just the plain old derivative of the log and exponential functions. So this tells us the derivative of the log function is 1 over x, and the derivative of the e to the x function is itself, e to the x. Now, we also have two formulas that help us if the input to our function is not just a plain old x. So for example, if we're taking the log of some function of x versus just plain old x, and the formula for that is you're going to put that input function on the bottom. Notice that agrees with what we had over here. The input to the log goes on the bottom. It's just that if you have a more complicated log function, you also have to put the derivative on top. And by the way, this is the chain rule. Applied to the natural log function. And similarly for the exponential function with base e, we get the same exponential function back, just like we did with the basic exponential function. However, we also have to multiply by the derivative of the exponent. And that again is because of the chain rule. So this one is the chain rule applied to the natural exponential function. So you do need to learn these, and let's see how to use them. So first, let's differentiate f of x equals 2 times the ln of x minus 3e to the x plus 5. So f prime of x, and be sure to label this, don't just write down the expression without saying what it is. And I'm going to actually put in an optional step here. So remember that constant coefficients just come along for the ride. So when I'm differentiating 2 ln of x, it's like 2 times the derivative of ln of x. And similarly, when I have 3e to the x, I'm going to have 3 times the derivative of e to the x plus 5. And again, you don't have to write this. This is an optional step. I just wanted to put it in so that I'm hoping the notes will make more sense. Now using our formulas, the derivative of the natural log of x is 1 over x. So I replace d dx of ln of x with 1 over x, because that's what it is. And then the derivative of, oops, I forgot to put in over here that we're also differentiating the 5. Okay, anyway, derivative of e to the x is e to the x, and we know that the derivative of any constant is 0. So we're going to simplify that as 2 over x minus 3 e to the x. And I suppose, really honestly, this is also an optional step. You know, if you can differentiate and simplify at the same time, that's just fine. Let's try one now where the input to the log function is not just a plain old x, right? The derivative, or the input to the log function here is a whole function of x. So for that, we're going to need the chain rule as applied to the log function. And that says, put the input of the log function down below, and on top, you're going to put the derivative of the input. And again, this is really an optional step. I'm just putting it in the notes to help explain what I'm doing here. So what we're going to get for f prime of x, we have a 3x plus 1 down below, And on top, the derivative of 3x plus 1 is just 3. And if you're comfortable doing it, you can just jump to this answer. Let's try another one. This time, let's try differentiating an exponential function where the input, in other words, the exponent, is not just a plain old x. So for that, we're going to need the chain rule as applied to the exponential function. Again, the way I know I need that is that the exponent is not just a plain x. So let's try that. The formula said that when I differentiate, I'm going to get the same exponential function back, but then I have to multiply by the derivative of that exponent. So we're going to have e to the x squared times 2x, which is better written as 2x e to the x squared. And again, I put in a step that you don't really have to write down. Write it down if it helps you get the right answer, but if you don't need it, you don't have to. Okay, and now we have a kind of a complicated one. We've got both exponential and log functions, and they both have complicated inputs. In other words, they both have inputs that are not the plain old x. So here's the optional steps. I'm going to have 9 times the derivative of e to the 1 minus x, and I know that derivative will be the same old exponential function, but multiplied by the derivative of the input function. Then for the log, I'm going to have 3 times the derivative of the log function, and our formula for the log function derivative, the chain rule one, says put the input to the log on the bottom and multiply on top by the derivative of that input. And again, this is an optional step. If you're comfortable just going right to 9 e to the 1 minus x times negative 1, and then we have plus 3 times. On top, we'll have a 2x plus 2, and down below we'll have an x squared plus 2x minus 1. So our simplified answer would be minus 9 e to the 1 minus x plus 3 times 2x plus 2 over x squared minus plus 2x minus 1. Okay, I hope that helps you with the differentiation problems in these two sections. As always, let me know if you're having difficulty, and I'm here to help you. That's what I'm here for.